Hi, this is Alex from devstories.eu. GitHub Actions, episode 13 of 14. You have a massive team, and at 9 in the morning, when 100 developers push code simultaneously, your static build servers either choke on the queue or you over-provisioned them and they sit there wasting expensive compute all night long. Kubernetes Scale Actions Runner Controller fixes this by turning your build pipeline into a dynamic, container-native system. Standard self-hosted runners are usually static virtual machines or long-lived containers. You set them up, register them to a repository, and they sit there pulling for work. This setup guarantees that you are paying for idle time, and when a sudden spike in builds hits, your queue simply backs up until an existing runner finishes its current task. Actions Runner Controller, or ARC, fundamentally changes that model. ARC is a Kubernetes operator that orchestrates auto-scaling runner scale sets. Instead of maintaining long-lived worker nodes, it provisions ephemeral, just-in-time runners based on the exact size of your queue. To pull this off without overwhelming API rate limits, ARC relies on two main architectural components inside your Kubernetes cluster. First is the listener pod. The listener uses an HTTPS long pole to connect to GitHub. Rather than requiring you to open inbound firewall ports to receive webhooks, the listener reaches out to GitHub and holds the connection open. It sits there quietly, waiting for GitHub to pass down a job available message. When the listener receives that message, it hands the information off to the controller pod. The controller acts as the provisioning engine. It immediately talks to the Kubernetes API to spin up a brand new runner pod specifically for that single pending job. This pod is a just-in-time ephemeral runner. It boots up, receives a short-lived registration token, executes the workflow, and then immediately terminates itself. Let's look back at that 9 a.m. code rush. 100 developers push commits at the exact same time. The listener pod detects the sudden burst of job available messages from GitHub. It alerts the controller, which instantly requests 100 ephemeral Kubernetes pods. Your cluster scales out, allocating nodes if necessary, and the jobs execute in parallel. As each workflow finishes, its pod is completely destroyed. By 9:15, the queue is clear, and your runner count scales all the way back to 0. You used massive parallel compute for exactly 15 minutes, and then stopped paying for it. Here is the key insight. Because every single job runs in a freshly provisioned, isolated pod that is destroyed right after execution, you completely eliminate state contamination between builds. A dirty cache, a leftover background process, or an altered environment variable from a previous run simply cannot break the next one. You gain the security of a pristine build environment every time, coupled with the exact compute efficiency of Kubernetes autoscaling. The true value of the Actions Runner Controller is that it stops you from treating continuous integration runners as heavy infrastructure you have to maintain, turning them instead into purely transient compute that only exists while a job is actively running. Thanks for spending a few minutes with me. Until next time, take it easy.